It began quietly on July 1st. Astronomers spotted what looked like just another interstellar wanderer, a faint, glowing streak racing through the solar system at nearly 87 kilometers per second relative to the Sun. At that speed, it could cross the Earth-Moon distance in under 80 minutes. But it wasn't the speed that stunned scientists. It was its behavior. Most comets slow, fragment, or stabilize when they reach the inner solar system. This one did the opposite, it accelerated. Its trajectory began to tighten, showing tiny but measurable course changes. Its coma doubled in brightness in mere weeks. Spectral data revealed unusual ultraviolet spikes and intense carbon dioxide emissions never seen before. It looked less like a frozen rock and more like a guided craft. Then came the breakthrough. James Webb's deep field sensors picked up something extraordinary, rhythmic pulses from the object's tail. Natural jets from sublimating ice are chaotic. These were not. They came at perfect 17-minute intervals, timed, deliberate, controlled. Webb, Gemini South, and NASA's Jet Propulsion Laboratory all tracked the pulses. The data painted a chilling picture. What had seemed like a harmless flyby was now on a trajectory that could skim past Mars at only 1.95 million kilometers, a cosmic whisper. Even a small increase in velocity, just a fraction of the measured gas bursts, could send it directly into the planet. It appeared to be steering. Researchers realized they weren't just watching a comet. They were watching something aim. From September 19th to 30th, each outburst subtly changed its path. The pulses lined up perfectly with Mars' orbital plane. Avi Loeb and his team at Harvard floated a bold idea: could this be an engineered probe? Radar echoes from the Mars Reconnaissance Orbiter and NASA's Goldstone antennas deepened the mystery. Instead of the fuzzy signatures typical of comets, they found sharp, metallic-like reflections, unprecedented in planetary science. And then there were the visuals. High-exposure images showed green, needle-like beams converging toward Mars, synchronizing with the object's exhaust jets. It didn't just look unnatural. It behaved unnatural. Loeb proposed a disturbing scenario: 3I Atlas might not be approaching Mars to pass by, it could be targeting it, or even delivering something. Probes. Spores. A signal. Nobody could say. But the approach was surgical. A direct impact at its estimated mass, about 10 billion tons moving at 57 kilometers per second relative to Mars, would release over 2 million megatons of energy. Thousands of times more powerful than Earth's largest nuclear test. It would gouge a 60-kilometer-wide crater and blast debris into interplanetary space, some possibly reaching Earth. Then NASA's updates stopped. Telemetry from Perseverance and the Tianwen-1 orbiter showed unexplained gaps. Inquiries about impact scenarios were met with silence. A leaked classified note contained 3 words: Impact Protocol Initiated. What did it mean? Insiders hinted that Earth-based stations had sent encrypted signals to every operational Mars asset. There's no known way to deflect or intercept 3I Atlas. So were those signals a warning? Or a preparation? If the object is intelligent, even partially autonomous, it might be responding to our energy signatures. By activating Mars-based systems, have we just confirmed to it that we're paying attention? Worse, did we signal back? Meanwhile, a team at the SEI Institute tried something unconventional. They converted the object's trajectory, closest approach times, and velocity into binary code, standard compression used in deep space communications. The result was chilling. The dates of its closest approaches, to the Sun, Earth, and Mars, matched resonance dates known from ancient civilizations: September 23, October 5, November 11. The last time a similar alignment occurred was during the 1908 Tunguska event. For centuries, astronomers assumed the heavens followed silent, predictable laws. Comets, asteroids, interstellar visitors, all just cosmic debris. Then came an object unlike anything we'd ever seen. It moved too fast, glowed too brightly, and whispered patterns into the void. Observation by observation, the story changed. This wasn't just another comet. This wasn't coincidence. This was choreography. Instead of slowing, It accelerated. Its luminous tail pulsed like an engine firing micro-thrusters, exactly 17 minutes apart. Each pulse nudged its trajectory closer to Mars, as if guided by intent. Synthetic materials appeared in its spectrum, carbon nanotube-like structures, engineered polymers, compounds no natural comet should contain. Something about the object felt alive with purpose. Then the pulses revealed a deeper layer. Neurocosmology teams discovered that when volunteers were exposed to those precise pulse frequencies, their brain waves synchronized, even in isolated rooms. The signal wasn't just mechanical. It was cognitive. Meanwhile, on Mars, strange things stirred. Orbital instruments detected rising xenon isotopes, warming fissures, and weak magnetic pulses matching the object's emissions, as if the planet itself was responding before it arrived. Seismic activity spiked near Olympus Mons. A low-frequency signal emerged from beneath the volcano, a spiral echo of the waveform emitted by the object. It was as if Mars were waking up. Ancient sky maps from Babylonian, Mayan, and Tibetan texts described a flame serpent curving near the sun and aiming for the red world. Pre-Incan carvings showed lines radiating from Mars eerily like modern debris dispersion models. Myth or memory? Warning or preparation? Across cultures, the same pattern: arrival, descent, signal, not just once, but cyclically. Perhaps it's been here before. The final alignment sealed the unease.